Nathan Foreman. Hello, Nathan. Are you there?
I am.
Hello. So, Nathan, how did you find the challenge?
Good. It was exciting, just kind of in a different path from where I typically work, but I did run a little short on time, so
As is the nature, the 24-hour, the joys of 24 hours.
it's almost as if I was set up to be limited by time to this point today.
Literally by design, yes. Just to remind everyone, so this was your challenge. Generate predicted thresholds for a new MP from previously manually set thresholds using AI, ML, SQL history, essentially anything at your disposal. We again caught up last night and I interviewed you to figure out what your approach would be. So let's play that video back and see if the reality matches what your plan was. Okay, so I'm here with Nathan Foreman now. We're just coming up to 8 o'clock here in the UK, and hopefully you've got an idea of how you're going to tackle your challenge. But before we get on to that, what challenge did you get? And let's hear it in your words in case it's changed slightly, because that happens.
Yeah, it will. So I got the challenge to bring some AI and machine learning into SCOM. Originally, it was kind of something to predict and write overrides, and I was struggling with shaping that out. But I'm looking now to use some predictive modeling with machine learning to give you an idea of when you might cross a threshold without actually having to wait till your CPU's pegged out or something like that, for example.
Very cool. So, based on past performance?
Yes. So it'll look at historical collected performance data from the data warehouse, and then it will predict when you would actually go over your set threshold, but predicting into the future.
That's very cool. How much like historical data do you need for that to kind of work? Is it a large data set? I've got no
So the
idea.
more data, the more accurate, but I haven't gotten far enough to testing that. So I'm using some of the machine learning tools I just found through a quick Google, and I guess more data, better modeling. But
Okay.
luckily, SCOM is good at holding data in the data warehouse and in a nice, strong format.
That's true. That will certainly help for AI and machine learning more specifically.
Yep.
Yeah. Okay, brilliant. Really cool. So I wish you the best of luck. I hope you managed to make it what you were hoping it to be, and we'll catch up with you tomorrow and see if what you've built matches what you've just said there and what changes. Thank you very much.
Hopefully it goes smooth. Thanks.
Indeed. Good luck. So clearly, Nathan, you had a challenging challenge, which is good. I'm really interested to see what you actually built and what it looks like. So enough waffle for me. Let's share your screen and see what it looks like.
Yeah, let's start with the fun stuff that I'm sure everyone's thrilled. So
I'm scared already.
Yeah. After going through it, I ended up with a singular spectrum analysis. So it's a spectral estimation based on an embedded time series. This is how it works, but I'll minimize it because I doubt there's any interest there. So when I ran out of time, what I was doing is I was creating an executable that you could run in SCOM, and then also going to create a UI because it'd be no fun to say like, hey, it's running in the background, trust me. And that's when I hit the split. So I finished the UI, and then the executable still needs to be just wired up to SCOM to run it. But I finished the UI because that would be a much cooler demo to look at it. So let's go in here. We're going to pick on one of the cookdown ops 16, and then you just set some credentials, all of which would come from SCOM when it was implemented as an executable, but the UI needs some to be passed in. And then you just need to select world. Let's look at, say, logical disk here, and megabytes free for an example. You just need to select an entity, which of course you'd only have to do once and then figure it out, and SCOM would just run it. But for our UI, we'll select SCOM02 on the D disk. You'll see on the left here, I have historical readings for the 28th of November up until the 30th, and then it's actually used the SSA forecasting, the singular spectrum analysis, to proceed from the 30th all the way up to the 4th of December using the historical information. And so this kind of delving long ways outside of SCOM, but that was part of the task. The configuration up here on the right is what is used along with the data from the data warehouse to train the forecasting model. And then we forecast out. So as you can see here, it looks like the disk is very slowly going down. 15 gigs, 19 megs, 15 gigs, 18 megs. And you can see the model kind of figures the same thing with down and then an occasional jump somewhere. Well, it looks like it just slowly tapers down. And with a confidence of 95%, we can say a lower bound and an upper bound. So that one's kind of boring. I found what's probably a serious issue for us to look into. When I looked at the C drive on our management server, you can see the readings on this one go from 4 gigs on a patch day down to 18 megs.
So yeah, that's a problem. This is our actual lab, right? So we have to actually deal with this like tomorrow.
We'll have to actually deal with this. But then if you go over and look, yeah, you can see we're down at 0 and 1 meg that we're bouncing. The forecasting now becomes much more volatile just because you've hit the bottom, and you can see the lower bound and the upper bound based on that 95th percentile are far wilder, just because there's so much volatility that the template was unable to give you a narrow binding. So then the idea of implementation was to take this and then run it with, whether it's CPU or something, run it out a week or two and say like, yeah, you're about to hit, we're about to run out of this resource based on our forecasting.
Mm-hmm. Very cool. Well, where to start? Oh, judges, what are your thoughts? Let's start there before I witter on.
Yeah, feel free to ask questions on.
I'm almost speechless right now because the complexity of the task and the approach and also the methods used within just 24 hours. There are whole teams which are working on such issues and challenges, and I'm really speechless, Nathan. It's a really great thing, and I think it will be a great start for the future for SCOM to just for the guys who are developing this to get more ideas based on what we just saw, and maybe to one day implement this and to have this in SCOM. Thank you for that. It's really super exciting for me to just look at it, and also curious what the other guys think.
Oh yeah, I'm also very excited on, seeing at least, the forecasting has always been something which was, missing in SCOM, and what people have been working on sometimes, right? But then quickly they kind of stopped working on it. So there were some possibilities, like I said earlier, but yeah, nobody's ever caught on and kept dealing with this stuff. And it is actually very interesting because you actually do want to see beforehand when you reach a critical path. So what you normally do is you use the thresholds, right? So if you set your threshold far enough away from the end, let's say from the 100%, you put it at 90%. And if you want to be more on time, you put it at 80%. So that was a trick you could use, seeing something coming. But this will actually try and predict when you are reaching the actual 0 point, and that is very interesting indeed.
And I thought there was some exciting stuff if you had looked at the distance between the upper and the lower bound to just change the importance of that warning too, to say this isn't very volatile, so it's important, or like, hey, you're all over the place, so you just need to manually look at this because I can't make sense of what the data is. But with that lower and upper bound, you now have the data you might need to at least make that decision, because it'll tell you within a 95% confidence it'll be between those based on what you passed it in.
Yeah, the confidence part is good in this, indeed. Yeah.
Cash, how about you? Thoughts?
Yep. Completely spellbound, right? I mean, the solution looks so simple. At the end of the day, when you look at the ending of a movie or the solution of anything, the problem, it always looks so simple. but then the thought flow that has put at the back end by Nathan, that this has been fabulous, and I'm sure the data, or the forecast gets more and more refined, more and more actual, with more historical data, right?
Yeah.
So, but yeah, great work, Nathan.
Yeah, it's
Thank
one of
you.
those things. So I'm assuming you didn't write. Did you write a machine learning
I-
engine?
Yeah,
Or
I
did
do
you
not have
find
any
something?
data science like education. Microsoft has ML.net, which interacts well with C#. So for something where you need 24 hours, of course, is a short window. But yeah, I was able to leverage a lot of what ML.net has to do some of that time series forecasting.
Okay,
And it
that
is
makes a
written
bit
in
more sense.
4.7.2, which means it might even fit into the SCOM console. That
Okay.
was my stretch goal.
But
That would have
still
been very
integrating
cool.
the solution within this time frame, building the UI and presenting the whole thing. It's really hell of a job. It's just
Thank you.
amazing.
And the
I
source
agree.
code is up on GitHub. We'll share it out after this. So there's nothing, cooked down or squared up specific in there. So you can take it, play with it. Interested to hear how it works for other people. It'll take up to 10,000 rows from your data warehouse to do your training, and then it'll train your model and see how it goes from there.
The thing, I'm not a judge, but the thing I really like about this approach is the fact that you've basically used an existing engine, which means that someone else could use that existing engine. So anyone looking to replicate this, obviously they've got the code, but they also have the engine. And
Yep.
Cash, thinking about potential, like seriously thinking about potential futures for the SCOM product. If it's a
Yep.
Microsoft engine, you have the secret sauce already, which is great.
Yeah.
Yeah, fantastic to see. Are there any other comments, any other questions from our judges? Silence, spellbound silence. It sounds
Not
like.
yet.
Exciting.
Well, that is exciting. Cool. Well, there's one thing that we have to do before we move on, which is to hear about your charity, Nathan, which is the South London Christmas Dinner Charity. So tell us more.
Yeah. So I'm actually going down there this Christmas as well. It's for people who were raised in either foster homes or an institutional type home. When they leave in the age range of like 18 to 25, Christmas is a very quiet period. So these guys set up Christmas dinners and invite them back. They actually cab them in to different locations. And so there'll be about 25 people there and then us volunteers. And it's just kind of to make it fun for people that don't have a family to go back to at Christmas.
Another very worthy charity. Well, I wish you good luck. We'll see
Thank
how
you.
you fare.